Hello, my name is Timothy Williston, and I'll be doing an analysis on student performance. We'll be using the CRISP DM for the analysis. So why is student performance important? So our nation's economy depends on a well-educated, high-quality workforce. It's super important. Our states spend very large amounts of their budgets on education, and for families, students do spend a lot of time in school, like around 180 days per year. So it's a huge part of our families and our economies. It's important to me because I have 4 kids. So learning what drives student performance is really important to our family in particular. How do we define it? Having a high GPA and good grades really gives opportunities. Maybe not every student is destined for college, but every student needs to have opportunities and the ability to do that. Let's look at the data. It came from a national survey of children's health. It is a multi-year survey that they do every year. The data is available in a SAS or a Stata data sets. The survey is done either online, mail, or by phone, and an interactive data query. So anyone without data experience can go in and query the data, look at it, and see what's going on there. Some of the survey topics you can see over here: child and family characteristics, physical and mental health status, health insurance, access to healthcare, medical, dental, family health and activities, the impact of a child's health on the family, as well as even neighborhood characteristics and statistics. For the 2023 year, there are 55,162 records in 456 columns. It is quite a large data set. A lot of the variables, if you look over here, here's a snapshot of the data dictionary. A lot of them are binary, like this question about depression. A lot of them use the Likert scale, like this one here. Always, usually, sometimes, and never. They're going to be treated like a continuous variable in the analysis. Let's look at the target variable. We're going to use grades as the target variable. It is defined as mostly A's and B's, mostly B's and C's, C's and D's, D's or lower, and the number 6 is the kids who do not receive those type of grades will be filtered out. I'll talk a little bit more about the data processing later, but here's where we ended up with the target variable, 59% or no, which is actually 2 through 5, mostly A's and B's through D's. And then yes will be mostly A's. All right, the data preparation was prepared in actually 2 different software, KNIME and JMP. There was advantages to both. Let's look. Well, let me go in and look at the process first. So the data was imported into KNIME, which is a really good node-based software. There was exploratory data analysis, some initial processing before I sent it to JMP. I needed to filter out and make it a little bit smaller. It was sent to JMP to do the latent class analysis and more exploratory data analysis. In some ways, it's easier there. It was brought back into KNIME. Then I processed and looked at some post-JMP EDA, exploratory data. I was able to create a cluster chart of the cluster, the LCA that we did in JMP. I'll talk about more later. We prepped the numeric data. Then prepped the categorical data and did some transformations there. It was sent to a column. Well, first after that, it was these 2 nodes. The random forest creates the variable importance. Then it was the final data was created, and then the modeling steps here. I will talk about more of that later, but basically very similar for each one. Then they're all sent to evaluation, combined ROC, combined confusion matrices, and accuracy statistics. First, the dataset was opened into KNIME, removed some columns with too many missing values. That was one of the issues. I removed basically any column that had more than 40% of missing values, and that took it from 55,000 to 32,000. There was just a lot of extra variables that we didn't need in that data set. All it was checked visually, ranges, missing zeros, histograms. I had to sort the columns alphabetically. The data dictionary was sorted by alphabetical. The data was not. So in order to match up some of the codes, which you can see here, a lot of the variables had codes in it, which had to be matched. Like this was the variable name. That was a bit of a chore, but we got it done. Renamed the coded variables to give them meaning. That's the variables I was just showing you. And then count missing values, created a row or created a column for that, and filtered out rows with more than 5 missing values. Then the data was sent over to JMP to perform a latent class analysis. KNIME does not do that. That was because a lot of these variables had a big difference. Like for instance, ADHD might have been 10% yeses and 90% nos. So a lot of the variables had a big wide range. So I felt it was a good idea to cluster those together instead of using the individual variables, use a cluster. There were several cluster sizes that were tried, 2 clusters, 5 and 3. 2 clusters worked out well because anything beyond 2 gave a really small percentage number, like you can see here. And for this one, for instance, red is yes, blue is no. So cluster 1 is generally mostly no for ADHD, depression, anxiety, behavior problems, and so on. Cluster 2, which is 25%, were mostly yeses to that question. Then after the latent class analysis, the cluster column was saved to the dataset. It was moved back over to KNIME for additional preparation. The extra columns were removed. Every row with missing values were removed. There was a lot that could not be imputed. Some of them were. Some of the ones that were continuous, I was able to impute. But the ones that were really not continuous, I decided to remove them because it still left 24,000 rows after those were removed. The target variable grades was transformed to the high grades, which I showed you earlier, and the missing count was removed. The variable importance was calculated after all the final data was basically ready for modeling. It was sent to a random forest learner, which sends out, one of the outputs of that is attribute statistics with the splits and candidates. There's basically a 3 level to that, 0, 1, and 2. This is the formula that I used with the splits and candidates to create the weighted sum. It was sent to Excel for further processing to create this chart. This is a really good representation of the variable importance. Does all homework, finishes tasks are 1 and 2, and here's our cluster variable from the latent class analysis that ended up to be pretty high importance for that. When I looked at this, there seemed to be a very clear distinction between these bottom 8 variables and the rest at the top. We had quite a few, so I felt it was okay to not use these in the final modeling. So once the variable importance step was done, I just decided to remove those last variables. Then the data was sent to modeling. The decision tree, random forest, and gradient boosted trees all use the same modeling workflow. There was 10-fold cross-validation, equal size. Well, that was to help, basically to partition the data set to create the conditions we needed for it to learn. We did some equal size sampling. Actually, for all of these, they were equal size samples so that any categorical variables that had a lot wouldn't take over the modeling. They went to a learner/predictor, and then were sent to scoring and ROC. All the scoring and ROC were combined so that we could see all of them together, figure out which is our best model. Then the artificial neural networks and the logistic regression, they needed a bit of extra processing. One-hot encoding was the first step. What that does is it takes all the categorical variables, creates a second or a column for each of the responses. It makes it 0 or 1. Then the rest of the continuous variables were normalized. So basically, from a range of 0 to 1 for each of those, that makes it so that like age, the parental age variable was from basically like 17 all the way to 70. That would overpower potentially in these models like a 0 and 1 binary variable. They went through the same tenfold cross-validation, equal size sampling, learner predictor, and scoring. The support vector machines, that had one extra step before it. It was only the top 5 predictors because the SVMs took a lot of processing power, and I couldn't, it wouldn't run super well on my computer unless I removed some of those. So the results came out to the top 3 were a tie. Boosted trees, artificial neural networks, and logistic regression came up to 0.802. I'm glad that it was above 0.8 because that's a good level to get to when you're looking at the ROC curve, which is the area under the curve whenever you the graph, the sensitivity versus the specificity, the true positive rate and the false positive rate. Going down a little bit deeper, the accuracy statistics were sent to Excel, basically just to make it look nice and make it easier to see. So one of the big things that we want to look at is the sensitivity, which is the true positive rate. The yeses is really important to, like, we really want to predict the yeses, the high grades. It turned out that support vector machines did this the best. Now, that's not the whole story, though. We really need to have sensitivity and specificity really close together, and as well as look at the overall accuracy of the entire model, all 4 of these in the confusion matrix. The boosted trees and neural network had the top accuracy, but I decided that boosted trees was the champion because the sensitivity and specificity were the closest together, and that really gives us a good balanced model overall. Deployment, it can be sent in several ways. The learner, like for instance, this is our champion, the boosted trees. It can be sent to a PMML, which is a predictive model markup language, which can be sent and used for other people in other softwares to make this information really useful. Also, new data streams can be sent in, and new data can be classified without training. So this analysis really is valuable to families. It's going to be valuable to me, nonprofits, teachers, school districts, and governments. It can really be useful for in many ways, and I hope that my family gets a lot of use out of it, as well as nonprofits who work with students, teachers obviously, and school districts and governments. Anyway, just want to thank you for tuning in to this analysis, and I hope you have a great day.